Brandon, we're sorry that you're gone, so I hope you're okay.
Allie said I could do it.
We're sorry you're gone, and we are working on this paper, which you have, I believe. You have this. Can you see it? This is the same one we were working on last time. We're just finishing up some notes on that. All right. So, very good. So, what were the objectives? What were the topics again? We were adding, multiplying, subtracting, and dividing every single data point by the same number and observing what it did to the center and spread. What's that word we used instead of adding, multiplying, subtracting, and dividing? Transforming. So putting all that together, this is where we were. Transforming data. Transforming. I can't spell on the board, I really cannot. It's in my head, but it doesn't come out my arm, so there must be some kind of Lexia name for that. Let's look at the first dot plot, which I colored in yellow on the top of mine. What was being evaluated there? What were those dots representing? Do you remember, Elena, what those dots were for? Whoops.
Chapter 2D.
Thank you. All right, we'll be right back to you, Elena. Bailey, what were they doing, those dots? It looks like this. No day 2. Okay. I got another one that you can have. All right, there's a new one. But put the notes on again, because those were the important parts. Transforming data. So, Bailey, what was going on? What were they plotting on this first one, which I have in yellow here?
They were.
Some teacher was doing something.
Some teacher was plotting. Oh, right. The chillins trying to guess and remember.
Right, the chillins, right. So the teacher collected data on how long the classroom was, and they put all the guesses there. So that, see the word guess in meters there. And then underneath in what we call the mini tab was all the data with the mean and the standard deviation, the quartiles, and so on. So then down here, can you see mine? Do you see all the yellow? All the yellow on mine is the same plot, same information. So you're aware that the plot up here of all the children's guesses is repeated down here. So you make sure that those are repeated. And this yellow one is the data for either this or this. They're the same. Now, Julia, what happened on this one? What was going on here when the one I circled there in purple, the one that's not yellow, what happened? All right, and what were they subtracting?
13.
Right, because that was what? What was 13 have to do with anything? Do you remember, Caleb? Why did we subtract 13?
Was the mean?
Pardon?
Was the mean?
Not the mean,
Median?
but
Median?
no. Why do you remember, Allie? Why they subtract? Why did that teacher take every?
Oh, the correct answer.
It was the correct answer.
Oh, sorry.
So what we're looking here at, Julia, and everyone, is everybody's guesses subtracted by the correct answer. So anyone who got 0 is doing really good. And everyone who got negative underestimated. Everyone who got overestimated. So it's an easy way to observe that. So then we made this observation by looking at the mini tab below for the transform data. We were able to come up with some conclusions about all of these things. All right, this is what I want to know if it shows up, Caleb. Is it able to focus on this?
Yeah.
Did you find it?
I found it!
Yay!
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 It was just in my book.
Okay.
Yay!
All right. Try to keep it in the spot. That way we can find it quickly. So this is data data points. We're talking about data points that have been added and subtracted by constant from every single data point. So the data points, there's been something added and subtracted. So when that happened, did the median change, I'm sorry, the X bar, did that change?
Yes.
All right, does that make sense? Here's the blob of data. We moved it over here. Does it look like the mean would have changed? Definitely. How about the median? Did that change?
Yes.
The median
Yes.
changed. C for changed. Quartile.
Yes.
Quartile 3. Inner quartile range.
No.
All right, because here's quartile 1, here's quartile 3. Inner quartile range is the difference between the two. So if I move it over here or over here, the inner quartile range did not change. No change.
No change.
Range,
No change.
standard deviation,
change.
and shape.
No change.
All right. So we had gotten through that pretty clearly. So then we went ahead and we multiplied. We took all the data points, and I think that's where we were about at the end. We took all the data points and we multiplied and divided. So what happens here? And we'll pick it up there. Q1, Q3, IQR. Range. Do you have this information on the paper? Somewhere in the note form? Okay. I'm not sure if we got through multiply, divide. Perhaps we did. All right. What happens on the back then? I see a picture on the back where in the top, the one I have circled on the back, can you see the one on the top, is identical to the one where the teacher subtracted 13 to see who got it right and who did very quickly. So what happened? Do you recall what's the spread out data? Do you recall what he did this time? Do you remember, Elena, what he did to this spread out data, Elena? Did you have a note on that? There's a little clue on the side where it says error in meters, and we're on the back. We have an error on meters, and what did he change it to? Right, and do you recall we had to multiply each number by the number of feet in a meter, which was 3.28. So they took every single data point in the circled area and multiplied it by 3.28, transforming the data by multiplication from meters to feet. So, looking at that spread out data, before we took our data and just moved it like this. Now we take our data and multiply it or divide it. We're going to shrink it or stretch it. So. All right, so what did we decide on that one? Bailey, did the X bar change?
Yes.
All right, it changed because we multiplied it by the actual number, which in this case was 3.28. Did the median change, Bailey?
Yes.
Quartile 1,
Yes.
quartile 3.
Yes.
What about the interquartile range? This time, because it's stretched out, the difference between quartile 1 and 3 also changed. The range, did that change, Bailey? And the standard deviation and the shape. Only one straggler hasn't changed. So if you look at the shape, you'll still see two nodes, two high peaks. You'll still see a skewedness. You'll still see the outliers. So the shape, we say, has not changed by multiplication or division. So this has to be clearly understood to get the work today, so I will leave it up. And if I have to do any other work, I'll do it in between. All right, now the last thing before we look at some problems, yes. Oh, thought your hand was up. What happens if I take some data points? Oh yeah, do you need a timer? How long do you think it's gone?
Probably
10 minutes?
8 No.
Should we just stop here? Just make
Yeah, we can go 5 more minutes. I'm sure I'm not going to last 15 minutes yet. All right, look at the next and the last data, the plots, the data plot, dot plots there. What's going to happen if I take some data plots and I multiply every single one of them by something and then add? What if I do both? All right, so that's what we're going to talk about here. And I didn't give you the answer. I'm going to ask your intuition to come out to play. So I'll do that in purple. It'll be erased.
Come on out.
All right.
Dude.
All right. All right. We have Celsius. We have a Celsius, but we're not used to thinking in Celsius. So the cabin temperature is in Celsius, and all the mini tab for the Celsius temperature is underneath of it. So I'm going to ask you to find a spot, and we're going to calculate the change in all of these statistics to when did we use Fahrenheit. So to do that, we need to know the formula. Fahrenheit is 9/5 times whatever the Celsius number is plus 32. So we're going to take each of these dots, multiply it by 9/5 and add 32. So let's talk about what's going to happen to the mean. So on the mini tab, Julia, what was the mean when it was in Celsius?
8.43.
The mean is 8.43. So, Julia, should we take that number and multiply it by 9/5? Does multiplication, is the mean affected by multiplication?
Yeah.
All right, so we're going to take it and multiply by 9/5. Everybody get your calculator out. I'm going to need
If it wasn't changed by multiplication, would you not multiply it?
If it what? Say that again?
If it wasn't changed by
Right.
multiplication, would you
Right.
not put it
Yeah,
in
you'll get the
equation?
gist of it as we continue. Well, now the formula causes us to add 32. Now, did addition change the mean as well? It did, so we've got to add 32. So both changes will affect the mean. So I need you to take 8.43, multiply it by 9/5, and add 32. That will be the new mean for Fahrenheit. So I need a number there. Anyone?
47.17.
47.17.
Are we adding 35 or 32?
Oh, it is 32. Sorry. What was the number then?
It's 47.17.
Okay, sorry. All right. Now, the median is also a measure of center, so it's going to be just like, we're going to do the same thing as we did to the mean. So, Julia, pick out the median this time.
8.50.
All right, and it's going to be affected by multiplication, and it's going to be affected by the addition. So I need that number. 8.5.
47.3.
What was it?
47.3.
Anyone confirm?
Mm-hmm.
All right, so onward down our list. Let's do Q1. Q1, is it affected by multiplication? It is. Is it affected by addition? It is. So Julia, what's Q1?
Q1 is 7.00.
9 times 9/5 plus 32. I need someone.
44.6.
44.6.
Yeah.
Anyone confirm?
Yeah.
All right, onward, Q3. Same as Q1. What is it, Julia?
It is 10.00.
All right, 10 9/5 plus 32.
50.
Is it 50 even?
Yeah.
Okay, good. 50 degrees, and I ran out of space, so I guess I can go up with the title there. All right, interquartile range, we have to be a little more careful because interquartile range is affected by the multiplication, but look, it doesn't change for the addition. So, first of all, what is the interquartile range? So, Julia, find the difference between Q3 and Q1.
7. I mean 3.
Okay, I was going to say that
Such a
too.
classic.
Where's my board erasers?